Hey guys, it's Miss Johnson and I'm here to bring you our second notes video for Unit 4. Today we're talking about the zero product property again, like we did in our first lesson video, but now we're going to actually do some factoring with it. So what happens if we are given an equation that is not factored yet? How do we handle that? What do we do with that? So let's talk about this from yesterday. Yesterday we looked at all these factored forms. We looked at the factored form of an expression and talked about how when it's set equal to 0, that tells us that we need to solve. And we also talked about how the zero product property allows us to split those two factors, each equal to 0, and solve each one individually. Okay, so that's great. So in number 1, I have x plus 5 times x minus 9 is equal to 0. I'm going to split that apart into x plus 5 equals 0 and x minus 9 equals 0. And then I'm going to solve each side separately. So on the left, I got to subtract the 5. I get x equals negative 5. On the right, I need to add the 9, and I get x equals 9. So my two solutions here to that quadratic are negative 5 and 9. And remember, we talked about how you can list them together. Typically, you'd see them listed together with a comma in between. Although if you circled the two solutions separately, that would be fine too. Either way gives you the correct answer. In number 2, I have 2x plus 4 times the quantity 5x minus 9, both set equal to 0. So that set equal to 0 tells me, oops, I forgot my v there, that I need to solve. So I'm going to have 2x plus 4 equals 0 and 5x minus 9 equals 0. So then I'm going to subtract the 4 and I get 2x equals negative 4. I'm going to add the 9 and 5x equals 9. On the left-hand side, divide by 2. These are two-step equations. Actually, both of these are two-step equations. So I have x equals negative 2. And then divide by 5, and x equals 9/5. So 9/5 can't really be reduced. You could make it a decimal if you wanted to, but typically you'll just see it left as a fraction like that. So we would have solutions of x equaling negative 2 and 9/5. All right. But now what happens when we get into expressions that are not factored? Well, if they're not factored, that means we have to do that work ourselves. So the first thing I'm going to do is factor this expression. So I've got the x squared plus 6x plus 5. That's my trinomial. I have a product of 5 and a sum of 6. So I'm looking at 5 and 1. That means I would split that 6x in the middle. I'd have x squared plus 5x plus 1x plus 5, all equal to 0. If you plug that into the box, it looks like this. X squared, 5x, 1x, and 5. And now hopefully we've done this quite a bit so that these factors are coming pretty quickly and pretty naturally to you. X squared and 5x is going to be an x. 1x and 5 is just going to be a 1. This first column, x squared and 1x, is going to be an x, and 5x and 5 is going to be a 5. I end up with x plus 1 and x plus 5. And that's where, because it's all still set equal to 0, I still have that, I still have that. So that's where I now split them apart. X plus 1 equals 0, x plus 5 equals 0. So then I subtract the 1, get x equals negative 1, subtract the 5, get x equals negative 5. So your two solutions are x equals negative 1 and x equals negative 5. Let's take a look at number 4. Again, I have a trinomial. I recognize that it's a trinomial because it has 3 terms. That's what that tri prefix means. So it has 3 terms. I also recognize that it is an x squared. That's what makes it a quadratic. Okay. Now, we talked very briefly at the end of the Unit 3 stuff about the shortcut that you can sometimes use in terms of factoring. And that shortcut comes into play only when you have a 1 in front of your x squared. You can't use it if you don't have a 1, but you can if you do. So in this case, I see that I have a 1 in front of my x squared. If I set up my factor x, I have 1 times negative 21, which is negative 21. The middle term is a 4. here's where that shortcut comes into play. So I find these two things. What gives me a product of negative 21 and a sum of 4? That's going to be 7 and negative 3. 7 minus 3 is 4. 7 times negative 3 is negative 21. Shortcut time. So because this is equal to 1, when A equals 1, you can use the shortcut. So what the shortcut tells you is these two factors become your parentheses. So I jumped straight to that step and I got to skip the box, which is lovely. It saves you a little time, saves you a little work. Again, it only works when A is equal to 1. That's when we can use it. If A is not equal to 1, you got to do the box and you got to find the GCF from there. Okay, so now I'm going to split these two because I'm already at that step. So x plus 7 is equal to 0. X minus 3 is equal to 0. Subtract your 7. I get x equals negative 7. Add your 3. I get x equals 3. X equals negative 7 comma 3. And you're good. There's your two solutions. Let's try the next one. So in number 5, I see that I have x squared minus 7x plus 10 is equal to 0. The first few things that I recognize is that this is in fact a quadratic. I've got x squared. I've got an a that's equal to 1, which is helpful. I have it set equal to 0, which tells me I'm solving. So I need to start by factoring it because it's not in factored form right now. And then I'm going to set each factor to 0 and solve. So in this case, my top number is 10 and my bottom number is negative 7. So what gives me a product of 10 and a sum of negative 7? That's negative 5 and negative 2. I need a negative times a negative to get a negative sum, but I need a negative times a negative to give me a positive product. Now, a equaling 1, that's helpful. When a is equal to 1, I can use that shortcut. So what that shortcut tells me is that I can use these two numbers as my sets of parentheses. I have x minus 5 and x minus 2 equaling 0. Now you're ready to split them apart. Oops, sorry, I lost my pen there for a second. X minus 5 equals 0 and x minus 2 equals 0. Add the 5. You get x equals positive 5. Add the 2. You get x equals 2. So your two solutions here are 5 and 2. There you have it. Let's try number 6. Now in number 6, my a is not 1, which means I'm going to need to use the box. A is not equal to 1, so no shortcut here. I have to use the box in order to factor, okay? So let's set up our factor x. I've got 2 times 3, which is 6, and I have a middle term of 7. That gives me 6 and 1 for my two terms in the middle. 6 times 1 is 6, 6 plus 1 is 7. So that's 2x squared plus 6x plus 1x plus the 3 equals 0. I always circle that because I've been known to pull that number instead of that number and make that mistake. So I always go back and circle the C term from the original so that I make sure I put the right one in the right spot. So it's definitely something I've done. Okay, so now let's put them in our box and factor. 2x squared, 6x, 1x, and 3. 2x squared and 6x is going to be 2x. 1x and 3 is going to be 1. 2x squared and 1x is just x, and 6x and 3 is going to be a 3. So your two factors there are 2x plus 1 and x plus 3. Now, don't forget, you still got to go and solve. That's the kicker of this. So we still have one more step. I got to split them and solve them. 2x plus 1 equals 0, and x plus 3 equals 0. This one, subtract the 1, 2x equals negative 1, and divide by 2. Sorry, I'm running out of room. You get x equals negative 1/2 there. Over here, subtract the 3, x equals negative 3. So my two solutions are x equals negative 1/2 and negative 3. All right, couple more examples that we're going to look at. In number 7, we have 3x squared plus 16x plus 5. Again, your a term is not 1. A is not 1, so we got to do the full-on factoring. A is not equal to 1, so no shortcut. So we're going to factor it using the box here. If I set this up, 3 times 5 is 15. Middle term is 16. I want a product of 15, sum of 16, that's 15 and 1. So split that 16 in the middle. 3x squared plus 15x plus 1x plus 5 equals 0. Sorry, my equal sign got a little messy there. Okay, now I gotta box it. I'm gonna try and write smaller so I have a little more space for you. So 3x squared, 15x, 1x, and 15. No, I'm sorry, hello, 5. See, I did it again. I wrote the wrong number down there. Okay, do you like my singing? I hope that entertained you for a second. Okay, so 3x squared and 15x. That's going to be a 3x for a GCF. 1x and 5 is a 1. 3x squared and 1x is an x. And 15x and 5 is a 5. So I have 3x plus 1 and x plus 5 equaling 0. Split them. 3x plus 1 equals 0. X plus 5 equals 0. Minus 1, 3x equals negative 1. Divide by 3, you get x equals negative 1/3. Over here, subtract your 5. You get x equals negative 5. So x equals negative 5, and I'm going to cheat and just daisy chain it off of this one. Negative 1/3 is my other solution. Sorry, that got really messy at the end there. All right, last one that we're going to do an example of. This one, a is equal to 1. Whoop, whoop. When a equals 1, we can use the shortcut. Yay, shortcut. All right, so here we go. We get the shortcut. So I can still set up my factor x. I've got 1 times 7, which is 7, and I got a middle term of 8. I need a product of 7 and a sum of 8. That's 7 and 1. And the nice thing about the shortcut is that means those are your factors. So x plus 7 and x plus 1, both equaling 0. Split the 2. X plus 7 equals 0. X plus 1 equals 0. Subtract the 7. I get x equals negative 7. Subtract the 1. I get x equals negative 1. X equals negative 7 and negative 1. Those are my solutions. It's kind of nice when you can use the shortcut and you get to skip this whole piece. So, all right, there you have it. So that's the zero product property when we have some factoring involved. So thanks for tuning in, and I will catch you next time.